There's something truly remarkable about watching raw iron ore transform into the steel that built America's skyline. At Salzgitter Flat Steel in Germany, they've perfected a process that would have made our grandparents' jaws drop. The journey begins in their towering blast furnace, where iron ore, coke, and limestone meet temperatures exceeding 900 degrees Fahrenheit. Think about that for a moment. That's hotter than lava. The molten iron flows like a river of liquid fire into massive ladles, each holding up to 300 tons. Now, back in the day, steel mills were dirty, dangerous places, but Salzgitter's modern facility uses advanced filtration systems that capture 99.9% of emissions. Next comes the basic oxygen furnace, where pure oxygen blasts through the molten iron at supersonic speeds, burning away impurities in just 20 minutes. The precision here is astounding. They're controlling chemistry down to parts per million. This isn't your grandfather's foundry anymore. The continuous casting process is where the magic really happens. Molten steel pours into water-cooled copper molds, solidifying into slabs up to 12 inches thick while still moving. It's like watching taffy being pulled, except it's 3,000-degree steel moving at 20 feet per minute. These slabs then travel through a series of rolling mills, massive machines with rollers weighing hundreds of tons, that squeeze and stretch the steel thinner and thinner, sometimes reducing thickness by 90%. The final product? Steel sheets so precise they're measured in thousandths of an inch, ready to become everything from automotive bodies to appliances that'll last generations. Remember when turning a piece of metal on a lathe meant standing there for hours, manually adjusting dials and hoping you didn't mess up? Well, let me introduce you to DMG's monoblock CNC lathe, a machine that would seem like science fiction to the craftsmen of yesteryear. The monoblock's foundation is, quite literally, revolutionary. Instead of bolting separate components together like traditional lathes, the entire machine bed is cast as a single piece of mineral composite material called granitan. This isn't just any concrete. It's a proprietary blend that dampens vibrations 10 times better than cast iron. Why does that matter? Because when you're cutting metal at thousands of RPM, even microscopic vibrations can ruin precision. The heart of this beast is its direct drive spindle motor, capable of spinning at 6,000 RPM while delivering massive torque. There's no belt, no gears, just pure electromagnetic power. The tooling turret holds 12 different cutting tools and can index to any position in less than a second. It's like watching a master craftsman's hands, except these hands can repeat the same movement to within 0.0001 inches, thousands of times without fatigue. Here's where it gets really interesting: the control system. DMG's Siemens-based CNC controller doesn't just follow programmed paths, it thinks ahead. Using something called intelligent feed rate optimization, it automatically adjusts cutting speeds based on material hardness, tool wear, and thermal expansion. The machine is literally teaching itself to cut better. The coolant system deserves mention too. High-pressure coolant jets, we're talking 1,000 psi, blast directly at the cutting edge, washing away chips while cooling the tool and workpiece. This extends tool life by 300% compared to flood coolant systems from the 1990s. What really takes you back is watching this machine work. The cutting tool dances across the spinning workpiece with balletic precision, peeling away ribbons of metal that curl and break exactly as programmed. It's manufacturing poetry. Here's something that'll take your breath away: turning a 25-ton rotor shaft on a heavy-duty lathe. This isn't delicate work. This is industrial might meeting precision engineering. The secret? Seco's SCMT38 positive inserts with Duratomic TPO 500 coating. That coating withstands incredible heat. We're generating temperatures that could melt aluminum at the cutting edge. The continuous cutting time is remarkable, with material removal rates that would have been impossible a generation ago. Watch that insert bite into the steel, peeling away ribbons of metal at impressive speeds. The screw-clamped insert design is beautifully simple, cost-effective yet incredibly secure. This profiling work on cast and forged superalloys demands both safety and productivity, and modern tooling delivers both. Now here is a process that really showcases the marriage of power and precision. Rolling a 20mm thick steel plate into a perfect cylinder is no small feat. That's nearly an inch of solid steel we're talking about. The 4-roll plate rolling machine makes it look easy, but there's some serious engineering at work here. The 4-roll configuration is a game changer, and here's why. That top roll doesn't just push down. It's powered and actually helps drive the plate through. The bottom 3 rolls work in perfect harmony, with the 2 side rolls being independently adjustable. This gives you control that was simply impossible back in the old days. The process starts with heating. 20mm plate needs to reach about 1,800 degrees Fahrenheit for optimal forming. Too cold and you'll crack the steel. Too hot and you'll alter its metallurgical properties. Temperature sensors monitor this constantly, ensuring we're in that sweet spot. Watch as the glowing plate enters the machine. The operator, and these folks are true craftsmen, adjusts the roll positions using hydraulic controls that can apply up to 500 tons of pressure. That's the weight of 5 fully loaded tractor trailers pressing down. The plate begins its first pass, curving slightly. Then it rolls back through, each pass bending it a bit more. The beauty of the 4-roll system is the pre-bending capability. Those side rolls can lift and curl the plate ends before the main rolling begins, eliminating the flat spots that plagued older 3-roll machines. This means less finishing work and tighter tolerances. Hydraulic systems maintain constant pressure as the plate thickness varies, because even in uniform plate there can be variations of a few thousandths. Computer controls adjust instantaneously, something a manual operator simply couldn't do. After several passes, that flat plate has become a perfect cylinder, ready for the longitudinal seam weld. The precision is remarkable. You can achieve diameter tolerances within a 1/4 inch on pipes 10 feet across. There's a certain pride that comes from watching something as substantial as a commercial truck come together piece by piece. At MAN Truck and Bus facilities, they're building machines that'll haul America's goods for the next 1,000,000 miles, and the process is absolutely fascinating. The journey starts in the frame shop, where massive steel rails, some weighing over 800 pounds each, are precisely measured, drilled, and assembled. These aren't just welded together haphazardly. Modern laser-guided positioning systems ensure every mounting hole aligns to within 2 millimeters across a 30-foot frame. Robotic welders then lay down perfect beads, creating joints stronger than the surrounding metal. I remember when welders did this by hand, sparks flying everywhere. Today's robots can complete 200 welds per frame with absolute consistency. Next up is the axle assembly line, and this is where engineering meets artistry. Each axle housing is machined to incredibly tight tolerances. We're talking variations smaller than a human hair. The differential gears are assembled in temperature-controlled clean rooms, because even a speck of dust could cause premature wear. These aren't just parts, they're precision instruments designed to handle 40 tons of weight while delivering fuel efficiency our fathers couldn't imagine. The cab construction line is like watching a metal puzzle come together. Galvanized steel panels, preformed in massive stamping presses, are spot-welded by dozens of robots in a choreographed dance. Over 3,000 welds go into each cab, creating a safety cage that meets the strictest European crash standards. The sound insulation process alone involves 12 different materials, acoustic foams, vibration dampeners, and multi-layer barriers that make these modern cabs quieter than luxury cars from 20 years ago. Here's something that would blow your mind. The entire electrical system is pre-assembled on specialized boards before installation. We're talking 5 miles of wiring, hundreds of connectors, all tested electronically before it ever sees the truck. Back in the day, mechanics traced wires with test lights for hours. Now, if there's a fault, the system tells you exactly which pin and which connector is the problem. The paint booth is a marvel in itself. Electrostatic painting systems ensure every nook and cranny gets coated using 40% less paint than traditional spray methods. Then comes the oven, a tunnel where trucks bake at 350 degrees for 90 minutes, creating a finish that'll withstand decades of road salt and summer sun. Final assembly brings it all together. The cab is lowered onto the frame by precision lifts. The engine, already tested on its own dynamometer, is mated to the transmission, and countless systems are connected and verified.